Okay, students, in today's lesson, we are going to have a look at completing the square for a quadratic function where the middle term is an odd term. Now, quickly revisiting what a completing the square is. Completing the square is a process where we convert the general form of a quadratic function, so which is y equals ax squared plus bx plus c, into the format of turning point form, which is y equals a brackets x minus h the whole squared plus k. So let's have a look at our first question. So we're going to try and convert this general form, quadratics, into its turning point form. So looking at the second term is a negative term, which means we're going to attempt to convert it into the format of a minus b the whole squared, which is a squared minus 2ab plus b squared. So let's write down the first two terms. So x squared minus 3x. I'm going to put my plus 5 aside for the moment. Now looking at the second term and the minus 2ab in our expansion of perfect square rule, we can see minus 2 times a, which in this case is x, times a missing number is equal to negative 3x. So looking at our mathematics and seeing what the missing number could be. Now we're converting a 2 into a 3, so obviously the number we're going to put in there is not going to be a whole number. So the value for b in this case works out to be 3 on 2. Because have a look at this, the 2 goes into each other, so which means we're left with minus x times 3, which gives us minus 3x. So the value for b is 3 on 2, which is a fraction in this case. Now going back to our expansion of perfect square rules, the third term is a b squared. So we're going to add the b squared to this to these two terms, so which means 3 on 2 the whole squared. But again, we can't just randomly add a 3 on 2 the whole squared, so which means we're going to balance it out by taking it away as well, so 3 on 2 the whole squared. Now looking at these first three terms, they now complete the square in the format of a minus b the whole squared, where the value for a is x and the value for b is a 3 on 2. So we now complete the square as x minus 3 on 2 the whole squared. Now let's deal with the rest of the numbers. So 3 squared is 9 and 2 squared is a 4, and then we have our plus 5. We can't add those two numbers because the denominators are not the same, which means we attempt to make the denominators the same. We now have 20 on 4, and simplifying our last step gives us a plus 11 on 4. So now we have converted the general form into its turning point form. Now what is the use of converting it to turning point form? We can easily get the coordinates of our turning point. So the coordinates of our turning point in this case is going to be a positive 3 on 2 and positive 11 on 4. Our y-intercept for this quadratic function, we substitute x as 0, which means we now have the value for the y-intercept as 5, which means the coordinates of the y-intercept is 0 and 5. One last step, which is to sketch this quadratic function. Draw a Cartesian plane, label our axis and the origin. We mark our y-intercept, which is 0, 5. Now turning point is 3 on 2, which is equal to 1.5, and the y coordinate is 11 on 4, which is equal to 2.75. So roughly plotting those points, so we now have 3 on 2 and 11 on 4. Now our quadratic function is a positive quadratic because the x squared term is positive, which means it's going to be U-shaped curve. We now join it with the U-shaped curve, and that completes the question. So again, the process is exactly the same for completing the square, except when the middle term is an odd number, we end up having a fraction in our completing the square rule. That's it for me today, students. Have a lovely day.